Here's section 3.5 for geometry. You're going to like this. It's a lot of algebra review if you like algebra and if you like lines. You're first going to be asked to write an equation of a line in slope-intercept form. If you can remember slope-intercept form, quick review, y equals mx plus b, where the m and the b, you probably remember, m is slope. I know, why isn't S for slope? Couldn't tell you. I've always been told that M was Latin for mountain or something. I think that was just so that I would stop asking. B is a y-intercept. And this one's a little bit more obvious that the y-intercept can't be called y because y is part of our function form of y equals mx plus b. You can't have two y's in there. I often refer to b as the base, because that makes sense, B for base. And it's also the starting point. If you were graphing, that's the base of your line. It's where you start. So if you were given just this information, that you knew the slope equaled 7 and the y-intercept equaled 9, you would write an equation of the line in slope-intercept form just as y equals 7x plus 9. Don't make it any more complicated than that. You're just making sure that you're putting them in the correct location. This one, the slope is 0, which reminder will mean that it's a horizontal line. Y equals, if you wanted to put 0x minus 3, you could, just for your own sake and your work, but it would, of course, be considered incorrect if you left it as y equals 0x minus 3. You want just the equation of a horizontal line, slope of 0, y equals negative 3. In the reverse order, this time your intercept is 0, but you do have a slope. So you have y equals negative 1/4. And to be sure that you know that it's the slope and not the intercept, of course, include the x in there. Y equals negative 1/4 x, which shows that it is a line with a slope. What if you have a slope that's undefined, but it just does tell you what point it's going through? If your slope is undefined, this is your graph, okay? An undefined slope means that it's going vertically through the graph. You don't have a y-intercept. It never actually touches the y-intercept, and the slope doesn't even exist because you have a rise but no run. And rise over run, if you divide by 0, it's undefined. So if your slope is undefined, you know that you have a vertical line. Where is that vertical line? Well, this one happens to be through 3 and 6. It's through that point. But if it's through 3, 6, it means it's also through 3, 5, and 3, 4, and 3, 3, and 3, 2, and 3, 1, and 3, 0, and 3, negative 1. All of these points are on that line. And every single one of these points on the x-axis, okay, touches the x-axis. Every point is 3 for the x value. It could go over 3 up 6, like it says here, over 3 up 100, over 3 down negative 2, down 2. So x equals 3 is your equation of a vertical line. And reminder up here, when the slope was 0, that means it was an equation of a horizontal line, because all of the y values were the same. Well, in this case, it was at negative 3. All of the y values were the same, and they all were negative 3. So a horizontal line has a y equals equation. A vertical line has an x equals equation. More complicated than that, we're going to talk about point-slope form. This point-slope form is given to you because you have a point, x1, y1, and you have a slope, m. And you're going to start out by plugging numbers into the point-slope form, but then simplifying so that you get back to the y equals mx plus b form, because slope-intercept form is just so much more user-friendly. It works better on a graph. It works better when you're comparing parallel lines, perpendicular lines, which we'll do in the next lesson. So this is one way to find an equation of a line in y equals mx plus b. You have been taught, I'm almost positive, a different method where if you know that this is x and this is y and this is m, you can plug it into y equals mx plus b and find m. That is an option, but I am going to show you this option because it's good to know two different ways. You might choose one over the other once you get to know them both. But this one is super user-friendly, and the algebra of it works out pretty slick. So, as I said, this is your first x and your first y, and of course it's the only x and y in this one, but the next problem I'm going to give you, there will be two x's and y's. This is your m. This y and this x up here in the formula don't have subscripts to them, which means they are the actual variables in here. So you're going to go y minus y1, which is 5, equals slope of negative 3 times x minus x1. We're going to have to pause that a second. Pardon the interruption. We'll carry on here. So we're doing x minus x1, and good thing I stopped because I started writing x1. Our x1 value is 4. Okay, the first thing to clean this up is to distribute the negative 3, so I'm going to leave y minus 5 over there as is. Distribute the negative 3x, which gives you negative 3x. And right here, by far, the most common mistake made in all algebra, geometry, algebra 2, pre-calc, calc, is forgetting that you're distributing a negative, and a negative times a negative is a positive 12. So common for students to just keep that negative right there, write it as a subtraction and put it there. But a negative times a negative is a positive. Then we're going to add 5 to both sides. And here's the nice, smooth, easy transition from point slope form to now you have y equals mx plus b form. Y equals negative 3x plus 17. And you could do a quick check. Check your answer. Yes, you have a slope of negative 3. If you plug the x value in here of 4, negative 3 times 4 is negative 12. Negative 12 plus 17 is 5. Or if you have a graphing calculator, you can throw it on a graphing calculator and check your answer as well. So, quick, easy transition from point slope form to slope intercept form. Every time you do it, it's going to be distribute and add, or distribute and subtract. Two-step solving equations. Okay, I'm only going to show you one of these, and now I'm going to move on to a graph because, again, this is review. If you need more work with it, I can get you some more work with it. Write an equation of each line, still in slope-intercept form. So we're looking for y equals mx plus b. And we can shortcut when it's given on a graph. As you can see over here, the graph already has a base. Our base is 4. Whether it's on a graph or you're given that point, you know that if x is 0, it didn't move left or right, it just went up 4. That's our b already. Okay, and we have the option of finding slope using the formula, or because we have this nice graph, we can shortcut it as rise over run. 1, 2, 3, 4, 5, 6 is our rise. Run 1, 2, 3. But because we went left 3, we're going to have to divide it by negative 3. Don't ever leave your slope as if it's unreduced or not simplified. 6 over negative 3 reduces down to negative 2. Now let me make a point of this, that if somebody chose to count the slope from this point and went down 1, 2, 3, 4, 5, 6, down 6, they would then go to the right 3 spaces, and a negative 6 divided by 3 is still a negative 2. Or that's one way you could check your answer. Also double check that you have a negative, because this is our little downhill skier right here. He's skiing from left to right. He's got his hat on backwards so that it doesn't fall off. And if he's skiing downhill, when he moves left to right across the graph, you better make sure that you have a negative slope. So we have our base of 4. We have our slope of negative 2, which gives us y equals negative 2x plus 4. Okay, if you take a look at this graph over here, it's going to take a little bit more work. We do not have a y-intercept. We do have a y-intercept. It's not exactly at a perfect whole number, so we'd have to pretty much kind of guess where that is, where it falls between 0 and negative 1. So instead of that, we're going to have to use the formula, but we can still shortcut the slope and count from here up 1, 2, 3, 4, 5, 6, rise 1, 2, 3, 4, 5, run is negative 5. excuse me, that doesn't reduce 6 over negative 5, but as you know, most calculators will only allow you to put either a negative in front of the 6 or in front of the 6/5 or just up in the numerator with the 6. So either negative 6/5 or negative 6 over 5 is our slope. We're going to take that and try to find our y-intercept from there. Y-intercept, you have your choice of picking either one of those 2 points. I'm going to go with this one, I don't know why, and plug it in as y minus y1, which is 3, equals slope, negative 6/5 times x minus negative 3. X minus negative 3. Go ahead and turn that to a plus right away if you'd like. And again, it's going to be a simple distribute and add, a 2-step problem. Distribute the negative 6/5 x here, minus, because you're distributing a negative, negative 18/5. Go ahead, you can leave it as an improper fraction for now. If you want to switch it to a whole mixed number, you can. Plus 3, plus 3. Did I just write minus negative? I think I did. Minus 18/5. Fix that. Add 3 to both sides. You're left with y equals negative 6/5 x. And then 18/5. Go ahead and use your fraction calculators. At no point am I still trying to judge you on how well or how fast you do fractions. I'm trying to help you understand point slope, slope intercept, slopes, intercepts. And this part, I strongly encourage you to use a calculator and not make the mistakes. But you end up with negative 3/5. And there's your final answer. Double check, make sure it makes sense. Yeah, probably this is negative 3/5, not a little, maybe a little more than halfway down between 0 and 1. And your slope is negative 6/5. One more type of problem. What if they didn't give you a graph and they didn't give you a slope? The only thing they gave you was 2 points. You could graph it and find the slope off of a graph, but that's not always the most convenient or the easiest way to do it. And so I'll remind you of our slope formula. Lowercase m equals, remember capital M is a midpoint. You take the second y minus the first y, divided by the second x minus the first x. Reminder that that's rise over run, which basically means you're just counting it on the graph if you do rise over run. This formula, I don't care if this is your second x and y or this is your second x and y, because let me remind you that whether you choose this point as your first or this point as your first, you're still going to get up 6, left 5, or down 6, right 5. Either way, you're still going to get a negative 6/5. So pick whichever y's you want and subtract them. I'm going to go with 2 minus 5 for my numerator. But remember, if this is your y2, this absolutely has to be your x2. You can't flip-flop them. 2 minus 5, 1 minus negative 2. Go ahead and make that a plus right away. You get negative 3 over 3. And you will reduce this all the way down to negative 1. I know this says rise over run. I don't want negative 1 over 1. Always simplify it as far down as it possibly goes. Your slope is negative 1. So now you have a slope and you have 2 points. You can use whichever one you want. Pick a point. I'm going to pick this one just because they're positive. A lot of times I do that so that I'm not subtracting negatives and having more room for error. Just a quick reminder, point slope form. We're going to plug them in as y minus 2 equals negative 1 times x minus 1. And I know that's not necessary to put a 1 there. You could just put the negative sign. It's fine as long as it's there just in your work and not in your answer. Y minus 2 equals negative x plus 1. And then I'm going to add 2 to both sides. And your final answer is y equals negative x plus 3. And again, I'll remind you, I just set it up here. If there is a 1 sitting here in front of this x, you're going to lose points on it. It's not considered proper math. It's just like spelling a word wrong in English. Y equals negative x plus 3. Write it all the way simplified. You want to check your answer because you want to make sure that you get do really well and have good knowledge. There's x, there's y. Plug it in x. The opposite of a negative 2 is a positive 2, plus 3 is 5, but it has to work for both points. The opposite of 1 is negative 1, plus 3 is 2. If they both work, then you know you did it right. So there's a quick, what to do if you, first of all, you have the slope and you have the intercept. Easy ones. What if you have the slope but not the intercept? Use the point slope form. What if you have a graph and, oops, I skipped it. What if we have a graph and what if you only have 2 points? Pretty much stays pretty consistent with the point slope formula, would work every time. So that's it. Good luck on your assignment with these notes.